All right. Hello again, everybody. I think that we've given enough time for people to sign in. And since we will be sending this recording when it's all done, all late attendees, late stragglers, can watch the beginning once this is all sent out. So in the meantime, I'd like to welcome you all, as I said before. My name's Henry. I'm your moderator today. And welcome to SAMA's Overcoming Data Annotation Challenges for Enterprise ML. So today's webinar, my very esteemed, talented colleague, Megan McNeil, will be walking you through some of the basic and less basic challenges of working on and developing computer vision models and just working through ML overall. So without further ado, I'm going to hand over the reins of this to Megan McNeil. Just a quick bit of housekeeping. If you have comments or questions, please use the QA panel, which should be on the bottom of your screen, to directly interact with us. And we will answer your questions either immediately in real time, if it's directly pertinent to the content that's being presented, or if it's something that a lot of people's asking, it's going to be addressed at the end. We invite you to put in your questions at any time. We'll see them all. Don't be impatient. Just keep them all coming. We'll answer as many questions as we can. Beyond that, if everybody can hear us, please feel free to raise your hand or just enjoy the show. With that, I'm going to hand you off to Megan.
All right. Well, thank you, Henry. And let's get this started. So here we are. From that perspective, a quick intro about me. Hi, I'm Megan. I'm a product manager here at SAMA, where I lead our 2D annotation product. So that extends from video to image, from bounding boxes to vector annotation to semantic segmentation with our raster product. So a full gamut there. I love digging into the complexity of these problems. It's really where I find the most value. And then in my spare time, I'm an avid cyclist. I also love to cook, and a great cookbook can never be beat. But less about me and more about the webinar that we will take a look at today. So taking a look at today, we're going to see three major components. The first one is recognizing pervasive data labeling challenges within your projects. So these are things that you might be experiencing today. The next one will be strategies to set up for success at scale. There are proven ways to make this process better, and that's what we'll explore within that chapter. And then we'll conclude with taking a look at what can an expert annotation service like SAMA do for you, and what differences can that make. We'll conclude with a few key takeaways, as well as a Q&A period at the end. Again, if you have any questions along the way, feel free to put them in the chat, in the QA. Henry is there. He's monitoring it at all times, and will continue to do so. So let's get started and start thinking about those data labeling challenges. Do these sound familiar to you? There are so many challenges when it comes to data labeling, but there are definitely some key themes that consistently come forward. The first one, the labels aren't well completed, or paired with the cost is probably higher than we expected, or again, we don't have enough data, and finding enough seed data or managing that can be quite a process as well to find the right aspects at different stages. And then even if you're all the way through all of those, it can be scale without expertise can be extremely difficult. We're going to take a stab at each one of these challenges today, starting with an exercise about data labels. So please join along with me on that side. So here's your challenge. Where are the people in this image? So take a while to just kind of take a look at it. A little bit of a cheating in that some of them have already been identified, but it might be easy to see just within this image alone that the children playing baseball are people, and that's the primary focus of the image. But it's important not to forget that there are the spectators in the background that should also be listed as people. So differentiating between those two groups and making sure everybody is identified. We'll go to the next one. Same challenge, different image. where are the people? Now, it's easy to say here, okay, there's probably a person for every umbrella that I see, but then can I see that person? And that's where the labels become a little bit more challenging, even in a very specific situation with a very simple prompt. So here I can probably assume that there's one person for every umbrella, but can I see them? Should I be annotating them only if I can see their face? If you focus in at the very end of the boat, there's definitely lots of people there, but can I see each person accurately enough to say that this is one single person rather than a group of people? Then finally, you can add in a different complication of, wait, don't include the children. Now, how do you identify the children for something that is even less clear? All this to show that adding additional factors, even with a simple prompt, can become quite complex. Then we can take that to the extreme example of now annotate the people. There are definitely a lot more people within this crowded baseball game. But which people do we really need to annotate? What is the value in thinking forward as to, yes, you could annotate every person, but thinking toward why are you annotating each person and what is your expected outcome to make sure that that matches perfectly to the expected outcome. All right, one exercise down and a prompt for everybody to continue. A pause to think. What are parts of the ML infrastructure that should receive the most resources? You should be seeing a poll within the Q&A right now that will prompt you to see what types should receive the most resources. So take a moment, think about it, and we'll see your answers rolling in. All right, I'm seeing a few answers coming in. Keep them coming, keep them coming. And I'll show you what some AI and ML professionals chose as well. So within this subset group, they were asked exactly the same question of to rank what should receive the most resources. That can be talent, that can be time, that can be money. Within that ranking, we see that collecting, curating, and cleaning data sets is a top priority for a lot of these professionals, in addition to data transformation and data engineering. In contrast, you'll see that data labeling is at the lowest rank within this list. Now, this doesn't indicate the value or the importance of data labeling. It simply indicates that we need to think about being efficient within labeling requirements to optimize spend and make sure that everything comes together. One of the ways that we are able to do that is having the balancing act between quantity and quality. So with these two factors, we can really drive through some efficiency moments. The first one is quantity. And there's a common assumption of more is always better. But if we shift our thinking in that approach, is that you should really be thinking about how fast you need to reach that minimum market. How fast you need to reach the market and what is the minimum to get there. Target that and then scale from there. By doing so, and by balancing that quantity perspective, you can then focus on the quality of the data that you then choose to annotate. And that's exceptionally important. It's not only the labeling quality, but also the data quality. You want to ensure that you are annotating a rich data set with diverse items as a foundation before you completely scale up the whole way through. So moving on to that. Now, very interesting. I'm looking at the results of the question to our previous one. I'm just going to flash up to the previous screen. In that, a lot of you actually feel very similarly to what a lot of these engineers do. So I'm seeing 50% within the creating, curating, and cleaning data sets as a preference, but I'm also seeing labeling is a very much a top response overall within this poll. Interesting, and thank you for contributing today and attending as such, as it really is an important process that we need to continue to keep an eye on going forward. All right, we talked about quantity and quality, and let's say that quantity and quality has moved forward and we really figured out that balance here. Now you're ready to get going and you're ready to scale up. But you might need a little bit of help to reach that. So here are a few key signs that help is needed. The first one, increasing in-house costs don't match the results or the return that they once used to. Recruiting and training annotators is becoming a burden and not a control factor as it might used to have been. And then thirdly, even with a great self-service platform, it can be really difficult to manage quality and differences between annotation style from one annotator to the next. This is where you might need more help along the way. However, that can bring on a few more questions, which might complexify the situation. So with all those factors, should I go with an annotation platform or with a full service annotation partner? Do you think I can crowdsource, or I should do it in-house, or maybe I'll outsource it altogether? And then another question that's really prevalent for a lot of companies is, should I manage this project myself, or do I need a project manager to help me along the way and ease that burden? All of these are very, very fair factors. But pulling it all together, what I would encourage is to find a partner that will help you to focus on having good data. And that's a really important factor, not just to look at the end result or different components of a project, but to focus on the overarching themes. So from your side, you need to understand what your objectives are and have clear requirements before engaging a partner. You need to ensure that your training data is representative of the outcomes that you want to target. And then finally, you need to assume and accept that you will need to correct for bias within your model. So that includes identifying and knowing where bias could come up, testing for that bias, and then curating and reiterating on those different cycles. Pulling that all together, those are thinking about the different challenges, but also some success factors of where we will continue forward on our scaling journey. So thinking about some strategies as we set up to scale for success at scale. A first question here, and an open-ended one for everybody. What does true scale look like? So you should be seeing another prompt in the chat. This one's open-ended. So thinking about adding in some criteria, maybe a one-line sentence could be great about what scale looks like for you. All right, I'll give a number. I'll get another minute or two to complete those answers. Maybe not a minute or two, a few more seconds, definitely. All right, Henry, give me the sign when we're reaching kind of that right proportion. Okay, so looking at all those answers, I'll take a look at those answers. Thank you for thinking about it. I'll go over a couple of what common answers could be for what true scale would look like. So a few different common answers. Maintaining quality over a large data set of data that might change over time could be an answer to what does true scale look like. Sustainable hiring, onboarding of annotators. So being able to scale up as your needs scale up. So having that adjustment and being able to go accordingly. And then last one is owned infrastructure. So having your ML pipelines thoroughly complete from A to Z and owning that A to B scenario. What I would say is that there are three key pillars to what true scale looks like, and all are very much within a consideration of those. So having a clear quality strategy, calibrations, and then plan for iterations. First, have a quality strategy. Seems simple to say, but the key to achieving a quality strategy is having a robust quality rubric at every stage. This contributes to your final goal of having consistently annotated data. So in the first place, get the right expertise. This is in regards to your annotators. They need to be trained within the tooling and have the specific knowledge to be able to reach the expected and right results right from the beginning. That can be a specific expertise, but it can also be being able to identify specific objects that might be difficult for others to see. The next one is having instructions and training be a part of this rubric as well. So having clear and comprehensive instructions take away the guesswork that might later on be seen within your data labels. The idea here would be to have a complete instructions for every possible use case. And that removes the judgment of individuals and leads to a more consistent outcome from one item to the next. That also pairs together with training. So that can be specific instruction-based training, or it could be specific tooling. So one tool might work better than another for a specific annotation type. And then pulling it all together into having error types and scores. So having a quality assurance feedback loop here to be able to define a quality penalty and a score. So should it be per object? Should it be per sequence? Should it be per frame? You can get extremely granular within these quality scoring, but it also is a key factor to having a feedback loop to those previous two steps of instructions and having the right expertise to have it be a holistic view from one to the next. This next one sounds simple, but is more difficult to do in practice, and that's be involved with calibrations. Calibrations are a critical component to working with an annotation team, especially at the beginning of the project. This is your chance to align and to grow together. It's definitely, we see in a lot of projects where you might not have everything identified from day one. And it's within the calibration process, you're able to identify where there might be gaps and to resolve those gaps early on. Setting up a daily, weekly, or bi-weekly cadence of meetings gives the opportunity and sets the stage of expectation, opening a dialogue directly with the team and understanding from that side. You need to keep regular access and keep reviewing stats, even at every stage. That includes late stages where maybe you've already built that trust with the team. Having that connection consistently throughout is incredibly important. And then finally, responding quickly and having a feedback loop for deliveries to be able to maintain the SLA, but to also feedback information in near real time to be able to give back and iterate on maybe missed opportunities, misconnections of the results, so that the team can then pull that back into their process. The last component is very simple, but it's to remember that it's all iterative. And this is very much an approach to the data preparation and data annotation, is that for some, we're thinking of it as a one and done scenario. But that's not how machine learning is created. It's a machine learning algorithm. It's really about model training and about iterating on from a base foundation of base training data, and then optimizing to account for diverse applications. So that could be for bias, that could be for new information capture mechanisms, different video types, images. You can go around the gamut of different types. It can even be for different variations. You can think of one aspect, one place in the world might be different than another place in the world. To account for all of these different variations, we should really be considering it within a loop that can iterate upon. Now, it's key to remember that it's iterative as you then look for a partner, because the worst thing that could happen would be that it's a strict in and out scenario, when really you might need to be able to adapt based off of new requirements and new things that are learned. Ideas of adding one parameter, taking away the next, needing to identify one item early on, while another needs to be more precise later. So having flexibility and adjusting along the way. So 3 different components, taking a look at what that means at scale. Now, what can SAMA as an expert annotation service do for you? So how do we take all of these learnings together, a partnership approach, and build in forward the SAMA value? The first, so SAMA Pro is our main platform, and the high value here is accelerating the speed of your model to market, and that's through consistent data annotation and efficiency. So a few ways that we achieve that. The first is having high quality data every time. And that's by having a comprehensive platform. So having ML powered labeling tools, different levels of control, customized analytics to really hone in specific criteria, and then also developable features. So getting your data in and getting your data out. So pulling all of those together are all great aspects within our platform, but you have to also pair that within the operations. And that's how we're able to deliver rapid results. So rapid results are all possible, especially within our calibration process. So early calibrations, it's a key factor within our teams to be able to have consistent feedback very early in the project, so that later in the project, when we're reaching scale and we have those targets to maintain, it's clear and we can execute accordingly. And then the final one is having proactive problem solving. And this is where we have our unique human in the loop of our annotators being experts. We're trained to look at your data, proactively identify those differences and choices which they might need to make, and raise them accordingly. It also extends to our project managers, who are experts in being able to manage these different situations and adjusting accordingly. Okay, a very intense, I was gonna say a very busy slide that we have here. I'm gonna take it part by part as I lead you through. We're going to spend quite a bit of time here. We're going to start on the left, looking at all of the different capabilities of the SAMA platform. So the SAMA platform is focused in on computer vision. That includes, everything from images to video, as well as to 3D LiDAR annotations. So a full round of support there, as well as a full round of capabilities within those annotations. So our vector annotation is very popular within our image and video workflow, so object tracking, as well as identification with segmentation. We also support segmentic segmentation for 2D, as well as key point labeling. So a few additional items there within our 2D product line. The other one is within our 3D product line. So fusing together a 3D LiDAR output with 2D is a key capability. Having fused labeling, a seamless experience between melding both of these aspects together. Now, how is that all possible? And that's possible with our powerful pairing of our ML-powered platform with our human-in-the-loop annotators. There's two different examples here. I'll start with the first. So the first looks specifically at an annotation-based example. So our ML-assisted annotation, this is based off of a library of diverse models and diverse use cases, being able to correctly identify an item and the edges with a polygon. When we pair that with our annotation workforce, they are uniquely positioned to be able to both validate those results as well as identify what needs to be annotated. So the combination of both of those, we found that there was a 300% efficiency improvement when we compared using this ML powered tool compared to not. So definitely a gain there about having smart and specific tools along the way. The next example within our QA step is very important to add confidence for our quality assurance team. So this was a feature Auto QA, and what Auto QA does is it prevents errors on submit. So it takes a look at the task just as it's being submitted to ensure that there's no labels that might have been missed. It can also go deep and be tailored to a specific use case to say, to look at, say, the number of frames which have been annotated, or specific shapes, numbers in specific spots if there's an expectation on that side. So having such a flexible check right before being done, when we take that and we pair it with our QA team, there are a lot that enables them to focus on the details, because a tool like that gives them the confidence that everything has already been completed at minimum. They're able to look at those edge cases, and they're able to raise different requirements as required. We found that in practice, this can save alone 1 to 3 hours of time per analyst per day. So really significant, and adding lots of confidence within that QA step. All right, so just to review what we're looking at here. So we're pairing ML platform with our human-in-the-loop annotators. So combining both technology with operations, leading towards those gains and delivering ML results faster to market. We're going to take a second to look through 3 different features that we have in our platform that support just that. The first is our ML object tracking solution. So this is within video annotation. So the idea is that you identify an object with a single bounding box, and you can predict forward a certain number of frames. In this case, it's predicting forward 100 frames. A road sign has been identified, and we'll see that those future frames are predicted, which is a lot more accurate than linear annotation, linear interpolation, and it's also a lot faster than annotating every single one of those frames individually, adding efficiency as a result by not needing manual intervention at every stage. This next one is sensor fusion between 3D and 2D. So this has been a key investment area to be able to merge together not only LiDAR and video outputs together, but to create a seamless experience between those two modes. So you're going to see at the top, within the main view, you have a LiDAR view or a 3D view of the scene. But then at the top, we have the video. So matching those two together, being able to see those videos right from the 3D output, combining both outputs together seamlessly, enabling shared tagging across. So adding a lot of different color to what is a point cloud, which might be lacking that information, enabling our annotators to have a complete view of the spectrum here. And then finally, we have a feature called inspect mode, which is a very simple concept that has been able to deliver a very clear value output. And that is for the item that is selected to keep it in the center of the screen and to focus in on it, even when the annotator changes between frames. So this simple concept enables that you never lose sight of the image. You're able to review in this case, the bounding boxes, the fit at every stage to ensure that we'll continue to move forward. All right, pulling all of those different features together that I've just highlighted, we've seen that it can deliver up to a 30% efficiency within a single task, allowing projects to be delivered faster without sacrificing quality or consistency. One of the best parts of our platform is that it's ever evolving alongside our clients and alongside technology. So it's definitely something that we continue to invest along as we partner within this space. All right, in conclusion, we've taken a look at 3 different aspects today. The first, data accuracy is a core component in model performance. It's critical to identify challenges and then iterate upon it. A data quality rubric paired with regular calibrations can ensure tasks are completed consistently every time, regardless of the annotator. And then finally, SemaPro pairs together our annotation platform with 10 years of human-in-the-loop experience to deliver high-quality data, high-quality labeling at scale. And pulling it all back together into this final slide, we saw at the beginning that we had 4 different challenges, and then here would be tactics of how you could overcome those challenges and key things to remember. So the first, provide clear instructions in all cases to remove the guesswork. Optimize spend by being efficient. Focus on quality and diversity to start with. And then finally, hire a partner with a track record and a plan. Thank you all for participating today. This is very much a high-level overview of the challenges within annotation, as well as looking into some details of the annotation space. If you're interested in any specific concept, I would very much recommend that you go take a look at our blog. That's where you're going to find some deep dives and some interesting articles, not only into features, but into aspects of the machine learning space, the industries, and different industries all together. And then on a future note, stay tuned for our next webinar, which will be about quality considerations at scale, hosted by another one of my colleagues, and that will come later in this year.
In fact, just to add to that, stay tuned for basically we'll be sending out email invitations that sometime next week. They do. There's lots to come. So Megan, thank you for all of that. That was a really, really good presentation. And we did have a number of questions that came in during your presentation. So I'm just going to give you the questions in no particular order. Here we go. This was like a pretty interesting one. It's a pretty foundational question. There was a question as to how data transformation is defined, or how we define it here at Sama.
Wow, I was going to say that's a very much a big topic question, and I'm not sure. I'm not sure generally that we have a specific definition at Sama, but we're really thinking holistically within that data preparation. So at Sama, we're able to suggest and to really focus in on the objectives. So enabling you to curate your data all the way to that final end goal of producing those annotation results. So pulling that together and focusing in on the data will allow you to then instead focus in on your model development, and really repeating that loop and keeping that collective together is a critical component.
Good. On a somewhat related note, someone asked how Sama assesses the performance of annotators.
So the performance of annotators can vary dramatically from one project to the next. One of the key components that we look at when we assess projects, so there's different items, but one of the key components is efficiency and time. So time is always a critical factor in that it then results in time to delivery and time to market. That said, there's also a complexity factor within data, and we can see from one item to the next that the complexity can shift. So it's critical to assess both the complexity and changes and shifts within the data, as well as that time, and we can see some proportional trends between both.
Good. Somebody asked a pretty specific question about the difference between rectangular bounding boxes, whether that's less efficient than other types of labeling, such as hexagonal or polygonal labeling. That's
I love that. I was going to say, Henry's wondering about this question, but I think it's a very good point, actually. And that all comes down to precision and what precision your model is requiring at what stage. So a bounding box is on one edge of, we have identified the object, but it's maybe less precise than having an exact per pixel annotation that you might see with a segmentic segmentation. If I were to show on the other side of the precision spectrum. So it's really about both matching what your model will best perform with, and it's also matching your budget. So you'll see differences in cost between all of those different items as well. And at one stage, bounding boxes might be appropriate as a getting off the ground, identifying the objects. Meanwhile, you might need to iterate towards polygons to be able to have a higher accuracy at a later stage.
Next, sorry, the questions are coming fast and furiously. I'm trying to keep up with them.
I'm loving them coming. Keep them coming in, everyone.
Okay. Let's hear. Somebody's asking something specific about what we support. Is dense video segmentation annotation supported, other than doing every frame independently? I'm not quite sure I understood the question fully. Did you, Megan, do you understand that question?
Yeah, so we, at this stage, so for video, so I demonstrated today a feature for ML object tracking. So that's something that we support today with bounding boxes. And you're able to reduce the number of frames that you need to annotate, and not every frame would need to be annotated. In terms of dense video segmentation, we could apply the same concept to that, where it's something that we haven't quite productized at a top level yet, but to be able to do the same type of tracking, but in a closer polygon format.
Okay. I'm going to dismiss that then. Somebody, I think, wanted a bit more detail on what a quality score should be based on.
Ooh, great question. And I'm gonna just do another self-reference of, there is a fantastic blog on just this on our website about looking at that. But the quality score should look at different components, and it should also match the instructions. So it's a process of taking a look at what needs to be annotated, what those edge cases could be, what that guesswork would be, and then pulling it back into what you would evaluate the task on. So it's almost in and out, and I would match both together.
Okay. I think this is a question on how we, here, let me just try to parse this question. I'll just read the question. Paraphrase slightly, how do we manage all our data and resources to ensure that every task is exactly as expected, I guess, in the quality rubric?
So there's a couple different aspects here of how do we take a look and make sure that every task is evaluated regardless of the annotator. So that's something that we pull into our process. So we remember that we started with those clear instructions. So that's one of the number one control factors that you have to ensure that something is executed the same every single time, regardless. The other factor that to pull in is that QA step. And that is a critical component to take a look at the results of multiple annotators before it even gets delivered. So taking a look at that, feeding back where there might be those personal differences, those personal judgments, and having another human in the loop associate to take a look at those items to make sure that we're normalizing across for those.
Okay. Here, sorry, there's still more. Give me a second. No, that's a question that we've kind of answered before, so I'm not going to relitigate that. No, that's kind of answered. That's kind of answered. I'm just going to address something actually pretty quickly just right now, because a number of people on this are actually asking about employment with Sama or at Sama. Look, we're constantly hiring, so just to let you know, please, by all means, speak to, reach out to HR at Sama, and those people are the right people to address those questions. Sorry, just got a quite fair few of those questions, so I thought I'd just address this all at once right here, and I'll get back to the substance of this webinar. Oh, in fact, we're actually out of time. Everybody, thank you for your patience. And thank you for your attention. We've actually completely filled our time here. Megan, do you have time for just one more question, or we're pretty much good to go?
One more question, and then let's call it to a close.
Okay, got it. So yeah, actually, most of these questions are all to do with quality. So I think we've actually answered everything that we could in your responses already. So with that, I'm going to close out the session, and so I'm just going to let everybody know here on the call that you should be expecting a video recording of this webinar in your emails shortly. And once again, please stay tuned for invitations to our next webinar, which should take place around December 1st. You'll find out way more about that very soon. Thanks for your attention, everybody.
Thank you.
Bye. Have a great day.